Well, thanks for joining today's meetup. This one will go a little bit quicker. I actually have a meeting after this, so I'll have to, I can't stay on for the full hour, but I think we'll have plenty of time to cover the topic. Basically, today's topic is something that comes up from time to time where I have a lot of customers that are trying to, start their journey into automation. And one of the use cases that they typically have is, depending on their current state of single source of truth, and those types of paradigms around managing the existing infrastructure. A lot of times there's those unknowns in terms of configurations, or folks that due to attrition, right, have come and gone, and maybe not kept to the best practices as much as possible. So there's a lot of different types of port configurations on switches that can be problematic depending on what you're trying to do in terms of modifying them. So today, really all it is just some techniques that I use to help make that a little bit easier, and to give you the ability to to effectively find anything that you need from a switch port, either through structured data or non-structured data, using a couple of techniques. So with that, one of the ones that's um, one of the primary capabilities that typically we use, aside from just looking at switch ports, is being able to gather the existing configuration state. So oftentimes we'll call that like dynamic documentation. Um, you know, the ability to ingest the configurations, and maybe even going beyond that to creating YAML files or other types of files to ultimately use for making configuration changes. So this is kind of table stakes, but it's very relevant in this particular instance, because we may not understand, or we may understand, but we may have a challenge depending on how many different types of switches that we have, where the naming conventions are different, the amount of ports are different, that type of thing. So I tend to initially lean on the network resource facts to determine what are the exact interfaces that that particular switch and model has. So this example here is just Nexus. So if you're not familiar with collections with Ansible, there is a fully qualified collection name, and it starts with the namespace. So the vendor is Cisco, and it's the Nexus OS collection. And specifically, we're looking at the Nexus OS facts. And it might be confusing because there's two different types of facts. So there's the inherent facts that are a part of Ansible facts that you can glean all of them, which if you do that, you're looking at like the hardware configuration and interfaces, but you may need more, or you may not need that particular output, right? So in this example, I have this gather subset. So the subset allows me to filter out what I don't want to pull down from the particular devices as I iterate through my inventory. So as I'm gathering these facts, I can effectively ignore those legacy Ansible facts. And that's what I'm doing here is I'm negating them, so that way I'm not taking up memory space that I'm not using in the Ansible controller where I'm running the playbook from. What I'm interested in specifically is the interfaces, and not all the interface configurations. So in these examples, I'm looking at hardware interfaces, in particular layer 2 interfaces, because I want to look at things like trunking, switch port modes that are enabled for either access or trunking, native VLANs, allowed VLANs, those types of things that are very specific to layer 2 interfaces. And then obviously I need to know which interfaces that I have ultimately to start from, right? So that I don't have to be aware of every switch in my inventory with the exact configuration of what those interfaces are. So I can learn that or glean that, by gathering network resource facts. There's another way of accessing these facts. You can access them directly from a resource module by using the state of gathered, and then you'll pull down that particular resource module's facts. So this is one way of calling it kind of at a high level, or I could run within a task that specific module. So in this case, it would be the Cisco.nexus nexus underscore interfaces, or nexus underscore layer 2 underscore interfaces. So that would, give me another way of pulling in the facts. But we're not doing it, in a particular task like that. We're just kind of doing it generically at a higher level in our playbook, so that we can make that information available in memory to all of our subsequent tasks. And that's what I need, is to be able to evaluate the interfaces as we move in, into the task of the playbook. So for me to understand, exactly from like an interface perspective, what's available, I need to look at the documentation, or I need to, go through one iteration of gathering those facts. And then I can see what we call the magic variables, those built-in variables that map to those attributes that are documented as part of that data structure that's available for configuring either, the hardware interface or the layer 2 interface. So for me to know that, I would want to, reference the documentation as one of the options, right? So just to give you an example, if in if the example is like, say I want to see like a description, descriptions live within the interfaces. But if I wanted to see, something VLAN related, that type of thing, then that would be layer 2 interfaces. So if we take a look, and I think I want to open this in a new tab on this window. Okay, cool. We should still share this once it comes up. So you can see that this is the data structure. So everything is accessed from config parameter as we're configuring devices in our task. And then we have all these parameters that are available for us that we can define, more specifically define with the variables that we create. So as we look through here, we have descriptions, duplex, all the typical things that we configure directly on an interface. But this may not encompass like everything in terms of all of the available configurations at the interface level. So that's where it becomes a bit tricky. So I look here first, and this is a lot easier because this is all structured data, so it's very easy to manipulate and to be able to parse to. So this is preferred, but there may be something here that's lacking. So this is what we have available. And if you wanted to see, examples, you can scroll down. But the big one here that I'm using is descriptions. So at a minimum, if I create descriptions that represent as close as possible those interface configurations, then I can search through them. But that's definitely not always the case. Or you may want to, include an additional vector to make sure that it has the proper description in being able to match, something else, another parameter that that you expect to be configured on that particular port, if you're trying to match, a configuration that way. So those are interfaces. We'll take a look at the layer 2 interfaces. So let me open that one up. And there's a lot going on here. So here's where we have, our different modes, either access or trunk, allowed VLANs, native VLAN. I'm using native VLAN in one of the examples just to match on something, a little bit lower level, because see how this is nested underneath the trunk. So we have dictionaries, but we also have those list elements too. And sometimes navigating to them is a bit of a challenge. So the second feature of Ansible that we're going to look at is select adder or attributes and map. So that way we can work with these dictionaries and be able to match on something in particular that we may not have, direct access to because of the listing component of it. So if I go back to here, and just a couple more slides, and then we'll get into the actual examples in the playbooks. So just a level set, right? So if you're not familiar with these particular filters, these Jinja filters, this is what we're going to look at today. So the select adder allows us to filter a sequence of objects based on attributes of the object in the list. So what this does is, if I have a dictionary in list, then I can use select adder with different conditionals right, to match something that's in that dictionary, and then it will go through and iterate through all of those entries for us, and then we can make those available, for subsequent playbooks. The way that I do that is I'll set a fact, based off of what these results are, and then we can further use it to either create a file or to do a debug to get the standard output on the screen. So we can list out, something, either the dictionary itself, or if we want to go even more specific, then that's where we can use the map parameters, or the map filter rather. So that way we can create like a very specific list, like flattening out that list of just something in particular that we want to list out. So in our case, we want to list out interfaces because we're asking, what interface is configured this way. So we just list out those interfaces for that particular host. But if we wanted to, we can also see the entire dictionary result from the select adder. And I'll do that by turning on the verbosity so you can see, what it was the step before we actually used the mapping. And then the third one here is really just to do the opposite. So if we have a sequence of objects and one of the attributes we don't want to match on, so we're kind of doing it in the reverse, then we can do the reject adder. So that way it'll list out, all of the ones that don't include something in particular. So you can kind of look at it, from the reverse lens in that regard. So here's an example, just a basic example before we get into the actual live demo component of this. So this is not a switch, it's in a router, and what we're looking at is tunnel interfaces. So what we want to do is look at these variables here, and you can see that I have this dictionary tunnel underscore interfaces, and then I have these two list elements, right? So it matches here on the name. So I just have the two tunnels, tunnel 0 and tunnel 1. And then as we look through all these other attributes that we can match on, we can select something, right? So under tunnel 0, we have an OSPF. So that's what I pointed out in this particular example. As we walk through it, you'll see that we can, evaluate OSPF, and because it only exists in the first list entry, then it'll print that one out only because it doesn't exist in tunnel 1. Or we could have did like the reverse, and did the reject adder type of thing too. So that way reject OSPF, and then it would only show tunnel 1. So, either lens would work fine in that particular example. So in the playbook, and I guess this is more important, hopefully you can see this okay. The font's not too small for you on your end. What we're doing here is we're created a debug so that we can print out on the screen the tunnel interfaces, but we don't want to print out everything, right? So what we're doing here is we're just mapping using the map filter, right, to the attribute equals name. So we have the two names here. So that's all that we're printing out is tunnel 0 and tunnel 1, as opposed to that entire dictionary. And then the second one is using select adder and the map attribute. So in this one, and I mentioned it here a few seconds ago, is I want to just match on OSPF. So I can use OSPF is defined, or if I want to do something even more specific, then we have other conditionals like equal to and search and match. And they're used kind of the same way, but differently depending on the data. So since we're using, this is structured data here, we could use the equal to, and it would work fine. But for this one, we're just saying that OSPF is defined. So the only one where it's defined is tunnel 0. So that's the only one that's printed out because we're mapping the attribute to just name. Now, if you just use select attribute and not the map, then it would have printed out this entry for tunnel 0, but it would include the entire list, or not the entire elements from the first list element. So it would print this whole component, or this whole entry out of all these key value pairs. So we just wanted the tunnel 0. So again, it's an easy way to just create lists of things that we're trying to figure out, like what interfaces are configured in a certain way. So where it's a little bit more interesting is switches, right? Because there's a lot of different configurations and reasons why we would want to check those before we make changes, or if we're going through some type of migration, or whatever that task is, it could be very difficult to manually go through thousands and thousands of switch ports, trying to analyze how they're configured. So that's kind of the genesis of this particular use case and pain point.